Okay, we're now continuing section 5.2. Number 5 we're going to do, or we have done in class together. Okay, so we're going to do number 5, or we have already done number 5 together in class. So let's move on to number 6. And number 6, it turns out, is very similar to number 5, but this one we are not going to do together in class. You guys have to do it on your own. So let me read it to you and then we'll set it up. You throw a ball straight up from a rooftop. Okay, so picture yourself. You're standing on a roof, you have a ball, you throw it straight up. The ball misses the rooftop on its way down and eventually strikes the ground. So you meant to catch it and you didn't. A mathematical model can be used to describe the relationship for the ball's height above the ground, y. So they're telling you that we're using y as the height above the ground after x seconds. So x is time in seconds. Consider the following data, and they give us a table. So someone magically knew that after 1 second the ball was exactly 94 feet above the ground. So someone was videotaping this or something. After 2 seconds the ball was 136 feet above the ground, and after 5 seconds the ball was only 70 feet above the ground. It's on its way back down. Now it turns out that the height of any projectile, anything on Earth, is modeled as a quadratic function, or it's going to be a parabola. Okay? So the question we have here is find the quadratic function whose graph passes through the given points. And this happens in real life a lot. A lot of things that occur in nature are modeled by a quadratic function, not just projectile motion, but other things like, I don't know, the decay rate of a certain chemical in water is often a quadratic curve. Okay? So what we do, actually what computers do, is you put your data into the computer, you say your best quadratic fit, and out comes a cool function that you can use then to make predictions. Well, what we're going to do is we're going to do it the old-fashioned way, and we're going to do it by hand. Okay? So I'm going to first of all rewrite this backwards. It's going to look a little backwards. This is our basic generic quadratic function. ax squared plus bx plus c equals y. Okay, why did I write that backwards? Because I'm now going to use the xy table up here. So I'm going to create 3 equations from these 3 points. If x is 1, then I know y will equal 94. So let's plug that in. If x is 1, 1 squared is 1, so I will get a plus b times 1 is b plus c equals 94. That's my first equation. Now I plug in the second one. If x is 2, I know y will equal 136. If x is 2, and I plug it in here, 2 squared is 4. So I will get 4a plus b times 2 would be 2b plus c equals 136. That's my y. And now my third equation occurs when x is 5. So when I plug it in here, if x is 5, I get 5 squared, which is 25a, plus 5b plus c equals 70. There is my system of 3 equations. And on this system, notice the thing I'm looking for are my coefficients, a, b, and c. Okay? Alright, so now let's get out our scratch paper and start solving this thing. You know, honestly, it looks to me like the easiest thing to do is eliminate c. So again, think about these as being numbered. Equation 1, equation 2, equation 3. So I'm going to take negative equation 1 plus equation 2. So let me write that down here. Negative equation 1 plus equation 2. So what would that look like? That would look like negative a minus b minus c equals negative 94. Equation 2 was 4a plus 2b plus c is equal to 136. And when I add down, I will get 3a plus b is equal to, wait, don't tell me, 42. Okay? So we'll call that equation 4. And I'll write it down here for later. So equation 4 is 3a plus b equals 42. Okay, now I'm going to do basically the same thing. I'm going to take negative equation 1 and add it to equation 3. Okay, so that would be negative a minus b minus c equals negative 94. And equation 3 was 25a plus 5b plus c equals 70. Now when I add down, I get 24a plus 4b equals negative 24. So let's write that down here and call it equation 5. 24a plus 4b equals negative 24. Okay, so now I've condensed it down to 2 equations with only 2 unknowns. The thing I want to remind you about this process is this is not the only way to do it. You could have made different choices and ended up with 2 different equations here and then gone from there. It doesn't matter, okay? So this is why you need to show me your work as clearly as possible. The way I'm showing it to you, that's how I want to see it on your paper, or else I won't know what you've done. Okay, so I think what I'm going to do is I'm going to use substitution. So I'm going to take equation 4 and solve for b, and I will get that b is equal to 42 minus 3a. And now let's substitute that into equation 5. 24a plus 4 times, instead of b, we're going to use 42 minus 3a equals negative 24. 24a plus 164 minus 12a is equal to negative 24. So let's see. 12a, if I subtract 164 from both sides, I'm going to get negative 188. Do you guys buy that? Negative 188? Okay, now divide both sides by 12. I get a is equal to negative, something's wrong. 1, no, that's not right. 6, no. Okay, let me pause and figure out where I screwed up. Oh, I know, I see it right here. 4 times 42, that would be 8, huh? So if that was an 8, that would be a negative. This is what happens when you try and do math in your head, folks. Let's see, that'd be 12, 9, negative 192. Okay, so now divide by 12, and we're going to get 1. 12 goes into 19 one time with 7 left over, 72. 12 goes into 72 16 times. Aha! There it is. See, I knew what we were supposed to get, so that's how I knew I screwed something up. But this demonstrates you don't know what you're supposed to get. And so if you made an arithmetic error like this, which is very easy to do, what I would do is I would try and find where that happened and then give you partial credit from then on out. Okay, so it's important because this would be a pretty minor arithmetic error if you did something like this, so you wouldn't lose a lot of points for it as opposed to some other major thing that could go wrong. Okay, so now that you've learned from my mistake, now that we find A, you have to back substitute to figure out what B and C are going to be. So it turns out that B is going to equal, let's see. So up there I knew that B is 42 minus 3A, so that's 48. So 42 and 48 is 90. And C is, let's see, if I put that back in one of the original equations, that's interesting. We're going to figure out what C is, and I'll let you guys do that. Let's see, A plus B plus C, so 90, negative 16 plus 90 plus C equals 94. So what is that going to be? I think C is 20. I think C is 20. Okay. So then we'll plug it back in.